Today we're going to be working on naming and writing formulas for binary ionic compounds. Recall from our activities and worksheets so far that a binary ionic compound, first of all, is going to have two elements. That's what binary means. And it's going to be comprised of a metal and a non-metal. The metal will always be the cation, which is positive, and the non-metal will always be the anion, which is negative. If you were to look at a periodic table, recall that the staircase divides the periodic table into two parts. The metals are going to be on the left side, and the non-metals are going to be on the right side. And as we just said, the metals will always be some kind of cation, and the non-metals will always be some kind of anion. So we're going to take these examples here. Let's start with the magnesium chloride. So recall that we learned what ions each of these will become. So Mg, if you look at the periodic table, is right here. It has 12 electrons and, of course, 12 protons. But remember that it's going to tend to have one of these numbers of electrons, which in this case is 10, the closest number. So if magnesium goes from 12 electrons to 10 electrons, it loses 2, and it becomes a positive 2 charge. And that is going to be for the entire column of the second column of the periodic table. So Mg is going to tend to become a +2 charge. Now let's look at chlorine. Chlorine is number 17. It has 17 protons, 17 electrons, but it's going to tend to gain 1 electron to have 18. So if it gains an electron, this whole column is going to be a -1 charge. So now that we know that chlorine is going to be -1 and becomes now the chloride ion, we have to make these match with pluses and minuses. As we learned on the ionic models activity that we did in class, you need 2 chlorides to match up with the Mg + 2, and that's going to be a neutral compound. So the formula would then be MgCl2. And we call it magnesium chloride. We always end in an IDE for the anion if it's a regular element. Okay, so now if we work our way through the rest of these, potassium and bromine are right here. Potassium has 19 protons and electrons. It wants to go back to 18 electrons. So therefore, it's going to lose 1 and become a +1 charge. While the bromine is right here, it's going to gain 1 electron to form a -1 charge. So if you have a K+ and a Br-, they match up. And that's why you would have formula KBr, and the name is going to be potassium bromide. If we look at sodium and nitrogen, sodium is right here. It's going to become a +1 charge. Bromine, again, nitrogen. Nitrogen is right here, and it has 7 electrons. It's going to gain 3 to have 10. So therefore, its charge is going to be -3. So now we have an Na+ and an N-3. We're going to need 3 Na+ to match up with that N-3. So the formula is going to be Na3N. Now, last but not least, we're going to need to look at lead. And lead is a little tricky. And in order to look at lead right here, what you have to do is you have to look at the top of your polyatomic sheet that also has the transition metals and other metals that have more than 1 charge. So if you look for lead, you'll see that lead can either be +4 or lead can be +2. It has more than 1 charge. In this case, I told you that it was called lead 2. So if it's called lead 2, that means it's the one with the +2 charge, which is right here. So we know that the lead is going to be Pb +2. And then we can find the iodide ourselves down here, which is right there. So again, it's going to gain 1 electron and become -1. And so we know that the iodide is -1. So we need 2 of them to match up with the +2 of the lead. And so the formula is going to be Pbi2. So you have to be careful with transition metals or ones that have more than 1 charge, but you would look at this paper right here, and you have to include in the name the Roman numeral, which tells you the charge, or there's also a special ending Plumbus is the OUS ending for the +2 of lead, and plumbic is the ending for the +4. And if you notice, all the ones that end in ic are the bigger charges. These are all the bigger charges. And all the ones that end in us are the smaller charges. Let's go down here. Of the possibilities. Okay, so the smaller charge ends in OUS and the larger charge ends in ic. Now, if we wanted to apply this to our homework, we could take a look at this worksheet, and I'll do numbers 1 and 7 with you. If you look at number 1, it's aluminum and fluorine. Again, you should understand these charges of +3 and -1, because if you look at the periodic table, aluminum is number 13. It's going to go back to having 10 electrons, which means it lost 3. So that means it must be a +3 charge. And we're putting that together with the fluorine. Fluorine is right here, number 9. It wants to gain 1 or tends to gain 1. So it's going to be a -1 charge. So those charges should make sense to you. If you did our little trick here of drawing them out, you'd have Al +3, and then you need an F-, you need another F-, and one more F-. So the formula would have to be AlF3. Now the next column asks if it's binary or ternary. Remember, binary means 2 elements, and that's what this whole section is going to be. So all of these are going to be binary for this entire section. And all of these are ionic because they are ions, pluses and minuses, as I told you here. So this whole section is ionic. And then we're going to name it. Remember, the metal just keeps its name, aluminum, and the non-metal changes its ending to IDE. So it's going to be fluoride. And remember, you owe it to yourself to spell fluoride correctly. Okay, so that's going to be number 1. Let's take a look at number 7. Number 7, I highlighted over here in the green because it's one of the ones that has more than 1 charge, and it was cobalt. Let's look at that again. Cobalt with a +2. So if you look over here, you'll see cobalt with a +2 is listed right here. So you have to tell the reader which cobalt it is by the Roman numeral, or you could say cobaltus, either way, when you name it. So because the cobalt has a +2 charge and the bromide has a Br- charge, which again, we could see from the periodic table because bromine is over here, it's going to gain 1 electron. So therefore, you're going to have 2 bromides to go with that cobalt. So that must be a COBr2 formula. Again, we're all binary ionic in this section. And when we name it, we need to either put the Roman numeral with cobalt 2 and bromide, or if you prefer, you could use that special ending of OUS, cobaltus bromide. Either way is fine. Usually the Roman numeral is probably the easier way to go. Okay, but the cobaltus again came from this special name for the cobalt +2. So you're gonna fill in this section in the same way that we just did these examples.